All right, so the next part of the unit is going to cover how to use matrices. So the first part, or the first lesson in this unit, I should say, is about some basic matrix operations that we're going to use through the rest of the unit. So the first thing we're going to talk about is how to add matrices together. Now, here's the deal with matrices. There are two different dimensions that go with matrices. We can talk about how many rows and how many columns a matrix has. So for example, if I were to draw you a matrix that looks like this particular matrix would have 3 rows across, and it would have 2 rows or 2 columns down. So we would say that this matrix is a 3 by 2 because it has 3 rows and 2 columns. Now that's going to be important because as we start moving through our matrix operations like addition, subtraction, multiplication, we have to be able to identify what the dimensions of my matrices are. So if I ask you about a 4-row matrix with 1 column, what that's going to look like is a tall, skinny matrix. It's going to have 4 numbers down, so there's your 4 rows, and then it's got 1 column that they're all stacked in. If I were to ask you about a 5-row matrix that has 3 columns, we're talking about a matrix that's got 5 rows across. So I've got 5 rows across the matrix and I've got 3 columns down the matrix. So that would be a 5 by 3 matrix. So when we talk about doing matrix operations like matrix addition, say I want to add up matrices A and B. Well, here's matrix A and here's matrix B. The only way you can do addition or subtraction with matrices is if you have matrices that are the same dimensions. So A here has 2 rows and 2 columns. It's a 2 by 2. B has 2 rows and 2 columns. It's also a 2 by 2. So I can add these together. So what I'm going to do is rewrite them down here so I can actually do the operations. And you're just going to add together the numbers that are in the corresponding places. So for example, since 2 is in the first spot and -4 is in the first spot, those 2 numbers are going to get added together. You get -2. You can take the -5 and the 3 and add them together, you get -2. Take the 8 and the 3, add them together, you get 11. Take the -1 and the 10, add them together, you get 9. So my result matrix, my answer matrix, is the 2 by 2 matrix, -2, -2, 11, and 9. Now, as I move into a problem like this one, I'm supposed to multiply matrix A by 3. So I'm going to write it out like that. And I'm supposed to add matrix C to it. So I get something that looks like this. Now here's the deal with this. This is called scalar multiplication. So all I'm going to do is multiply every number inside matrix A. I'm going to multiply it by 3. So matrix A becomes 6, -15, 9, and -3. And then I'm supposed to add to it matrix C. Now here's the deal with this. You actually cannot add these together because they don't have the same dimensions. This matrix here is a 2 by 2, 2 rows, 2 columns. This one here is a 2 by 3. It's got 2 rows and 3 columns. So this operation is actually not possible because the dimensions don't match. So you would write down that they're not possible and you would give me some kind of explanation. Like if you show me that those 2 dimensions are different, then that's you telling me I know that I can't add them together because the matrices have different dimensions. Now multiplication is not as straightforward. When we multiply matrices, the first thing you're going to have to do is identify what your dimensions are. And here's why that's important. After you've identified what your dimensions are, that was going to tell you whether or not you can actually multiply the matrices together. So for example, if I use matrix A and matrix B here, matrix A is a 2 by 2 matrix, and matrix B is a 2 by 1 matrix. This explanation here is saying these inside numbers have to match. If those 2 numbers are not the same, you can't multiply the matrices together. Since these two numbers match, that means that you can, and your answer matrix is a combination of the outer numbers. So when I multiply matrix A and B together here, I'm going to get a matrix as a result that has 2 rows and 1 column. So the inside numbers have to match, the outside numbers tell you what your new dimensions will be. Now here's the deal with matrix multiplication. It is not commutative. So you've learned all through math that it doesn't matter what order you multiply things in, you get the same answer regardless. So for example, 5 times 3 is 15, and so is 3 times 5. Matrix multiplication does not follow that rule. So here's a case in point where it doesn't work. If I take matrix A and matrix B and I switch the order that I'm going to multiply them in, matrix B is a 2 by 1 and matrix A is a 2 by 2. When I multiplied them A times B, I got an answer that was a 2 by 1 matrix. When I multiply B times A, I can't even multiply them together because the inside numbers don't match. This multiplication is not even possible. So the order in which you multiply matrices actually is very, very important. So how do I multiply matrices together? You're going to hear me say this a lot. Rows by columns. So what you're going to do is you're going to take each row in the first matrix and you're going to multiply by each column in the second matrix. Rows by columns. So for example, if I'm going to use matrix A and B here, what I would do is I would write matrix A first, 2, 0, 1, and 1, and write matrix B second, 1 and 2. So what do I mean by rows by columns? You're going to take the first row and you're going to multiply it by that column. So let's talk about what that's going to look like. If I multiply this row by column, you're multiplying 2 by 1 and 0 by 2. So if I multiply 2 by 1 and 0 by 2, you're going to take those numbers and you're going to add them together. You're then going to take the second row and multiply by the same column. So if I take those numbers and multiply them together, 1 times 1 and 1 times 2. And what you're going to have is a new matrix. If I simplify a little bit, 2 and 1 is 2, 0 and 2 is 0, 1 and 1 is 1, 1 and 2 is 2. If I simplify my matrix, I get a final answer of 2, 3. So when I multiply those two matrices together, that's the result. And like I said in the original part of this, we were supposed to get a 2 by 1 matrix, which this has 2 rows and 1 column. So we have the right dimensions. This process can be a little tricky, so I've got some examples so that we can do some practice. So these are both 2 by 2 matrices. So I'm going to take and multiply these. I'm going to do A times B, so I'm going to write it that way. Now, since this is a 2 by 2 matrix and this is a 2 by 2 matrix, the multiplication is possible because the inside numbers are both 2's. The result is going to be the outside numbers. So I know I'm going to get a 2 by 2 matrix as the answer. So here's what I'm going to do. I'm going to draw myself a 2 by 2 matrix. So I've got 4 slots. I like to have the template drawn out so that I have something to fill the numbers into. So I'm going to go space by space. Row 1, column 1. So you're going to take and multiply the numbers. 5 and 1 gives me 5. 4 and 9 gives me 36. The second slot, you're going to stay in the first row and go to the second column this time. 1 and 0 is 0. 4 and 6 is 24. Go down. We're going to go to the second row, first column. 3 and 5 is 15. 2 and 9 is 18. Last spot, I'm going to go to the second row and the second column. 3 and 0. And 2 and 6. So once I've gotten all of that, now my problem is just a matter of cleaning up the answer. So if I add 5 and 36, I get 41. If I add 0 and 24, if I add 15 and 18, and if I add 0 and 12. So there is my result matrix from multiplying matrix A and matrix B. Now, to prove my point about switching the order not giving you the same answer, we're going to use the same exact matrices in the second problem, but this time we're going to flip them around and do B times A. So I'm going to write them in that order. And since this is a 2 by 2 and this is a 2 by 2, again, we can multiply. The inner numbers match. The outer numbers give you the dimensions of your new matrix. So I'm going to have 4 slots to fill in again. So I'm going to draw my template. And then we're going to go row by column. First row, first column. Multiplying 5 and 1, 0 and 3. I get 5 and 0. First row, second column. 5 and 4, 0 and 2. I get 20 and 0. Second row, first column, 9 and 1, 6 and 3. You get 9 and 18. Second row, second column, 9 and 4, 6 and 2. You get 36 and 12. Again, the final part of the problem is just to clean up the answers. So in each slot, I get 5 and 20 across the top, and I get 27 and 48 across the bottom. So just by flipping the order, the same 2 matrices gave me 2 totally different answers. Let's talk about, we're going to skip number 3 because we did one with those dimensions already. Let's talk about number 4. In number 4, this is a 1-row, 2-column matrix. This is a 2-column, or a 2-row, 2-column matrix. So the dimensions match because the inner numbers are the same. Remember, the outer numbers tell you your new dimensions. So this is going to be a 1 by 2 answer. So I'm going to draw out a matrix template that looks like that. And you're going to take the rows in the first matrix and multiply by each column in the second matrix. So if I go row by column, I've got -1 and 8. I've got -1 and -6. First row, second column, -1 and 2, -1 and -9. And so if I clean up my answer, I've got 2 numbers on the inside of my matrix. I've got a -2 first, and I've got a +7 second. So there's my result matrix. We are going to do, instead of doing all of this problem, we're actually only going to do part of it. So I'm just going to do A times C. So let's talk about doing A times C. Here's matrix A. It is a 3 by 2, and C is a 2 by 2. Since the inner numbers match, I know that the outer numbers are going to give me my new dimensions. So I'm going to write these matrices next to each other. I'm going to do it on a different piece of paper so I have more room. So -1, 2, 3, 0, 4, 1. Okay, so I know I'm going to have a 3-row, 2-column matrix because that's what the dimensions tell me. So I'm going to make a template. So I just have spaces to put all those numbers in. And we're going to go row by column. So row 1 gets multiplied by both columns. Row 1 by the first column. That's going to give me 4 and 2. Row 1 by the second column. -5 and 0. Second row by the first column. That gives me 12 and 0. Second row, second column. That gives me -15 and 0. Third row, first column. That gives me -16 and 1. That row, last column, 20 and 0. So again, my last portion of the problem when I'm doing this kind of problem is to clean up the answer. Across the top row, 6 and -5. The second row, 12 and -15. Last row, -15 and 20. Rows by columns when you're doing matrix multiplication. Rows by columns, rows by columns, rows by columns. We've got 2 more operations we're going to talk about. One of them is called finding a determinant. A determinant is something that you can only do on a square matrix. Only on a square matrix. So what do I mean by square? Square matrices have the same number of rows as they have columns. So for example, a 2 by 2 and a 3 by 3 are square matrices. You can also find determinants of 4 by 4s, 5 by 5s, and so on. We're not going to go that far. We're only going to do 2 by 2 and 3 by 3. So let's talk about 2 by 2. It's very easy. All you're going to do is take the main diagonal and the other diagonal, and you're going to multiply them, and you're going to subtract the values. So if I multiply A times D, that gives me the first number. B times C gives me the second number, and all you're going to do is subtract the two numbers. So if I find the determinant of my first matrix here, all I'm going to do is multiply. 10 and 2 gives me 5 and 2 gives me 10. 3 and 1 gives me 3. And all I'm going to do is take those two values and I'm going to subtract them. So if I subtract those two values, 10 minus 3 gives me a determinant value of 7. If I do the second one, multiplying that first diagonal gives me 18. Multiplying the second diagonal gives me 0. So the determinant, 18 minus 0, is 18. 2 by 2 determinants are very, very easy. 3 by 3s are a little complicated, as you can probably see. So let's discuss what all this is. The first thing you're going to do, you're going to take the first two columns. They get recopied over here. So notice that A, B, D, E, G, H all get recopied. A, B, D, E, G, H. So the first thing I'm going to do in this matrix is recopy the first two columns. So 2, 4, 3, -1, 1, and -4. All you're going to do at that point is multiply a bunch of diagonals. You're going to go down 1, 2, 3 times, and you're going to figure out what those three numbers are and add them together. First diagonal gives me -4. Second diagonal gives me 0. Third diagonal gives me 48. You're then going to go up the second set of diagonals. So as I go up those diagonals, give me one sec. As I go up, oh, that's going to be too bright. Let's see, give me a black pen. That'll work. All right, so we're going to go up this way. If I multiply those, I get -9. If I multiply the next diagonal, I get 0. If I multiply the last diagonal, I get, looks like +8. You're then going to take those values and you are going to subtract them after you've added them together. If I add these together, I get 44. If I add these together, I get -1. So if I take 44 and subtract -1, my determinant value is 45. One more determinant problem. First thing you're going to do is you're going to recopy the first two columns. So 4, -3, and 0, -1, -2, and 5. You're then going to take and multiply down the diagonals first. First diagonal, you get -8. Second diagonal is 0. Third diagonal gives me -30. You're then going to subtract, multiplying up the diagonals. First one, 0. Second one, -20. Third one, +3. Finding the determinant, you're going to add the values and then subtract what you get. This gives you -38. And I'm going to subtract off, it looks like -17. -38, subtract -17, that's going to give you a -19. So that would be my determinant value. Now, what are we going to do with that value? We're going to talk about that next class. Right now, it's just a matter of, can I find the determinant? Last operation we're going to talk about, how to find the inverse of a matrix. Inverse of a matrix can only be done with a square matrix. And again, we're going to focus on 2 by 2 and 3 by 3. 2x2s are the only ones that we're going to do by hand. You can do a 3x3 by hand. You can do a 4x4 by hand. It gets a little complicated for what we're going to use it for, so we're not going to do that. We're just going to do 2x2s by hand. So here's the first thing you're going to do. Number one, you are going to find the determinant of A. Number two, you're going to jumble up the matrix. How are you going to jumble them up? You're going to take and switch the first diagonal. So notice A and D switch places, so they are now D and A. And you're going to take the second diagonal and you're going to change their signs. Notice how they've become negative B and negative C. You're then going to do scalar multiplication, and that will tell you your inverse matrix. Those are your steps in order to find the inverse of a 2x2 matrix. So the first thing I'm going to do here is find the determinant. Again, diagonal and diagonal. So 6 and 4 gives you 24, 2 and 1 gives you 2. So my determinant is 22. You're then going to take it and notice that you're going to write it as a fraction. 1 over 22. And here's where you're going to switch the order of your matrix. The first thing you're going to do is take the main diagonal, the 4 and the 6. They are going to switch places. The other diagonal, you're going to take and switch the signs of the numbers. So positive 1 becomes negative, positive 2 becomes negative. To find the inverse, all you're going to do is do scalar multiplication. So if I multiply that 1 over 22 into the matrix, I get 4 over 22, negative 1 over 22, negative 2 over 22, and 6 over 22. If your fractions can be reduced, they should be. So the first one becomes 2/11ths, negative 1 over 22, negative 1 over 11, and 3 over 11. That is your inverse. Now, why do I care? What are we going to use it for? We'll talk about that next class. Right now, all I'm worried about is, can we find it? So that next class, we can then use it to do something. Last problem, going to find again the determinant. First thing, multiply your diagonals, negative 8. Multiply your diagonals, negative 20. You're always subtracting, so negative 8 minus negative 20 is going to turn into a positive 12. So you're going to take that number and write it as a fraction. And then you're going to switch up the order of your original matrix. First thing you're going to do, take the main diagonal and switch them places. So 8 goes up, negative 1 goes down. The other diagonal, you're going to flip the signs. That becomes a negative 5 and a positive 4. You're then going to do scalar multiplication. So if I multiply 1/12 in there, we get 8/12ths, negative 5/12ths, 4/12ths, and negative 1/12. The only thing left for you to do is to simplify any of the fractions that reduce. So if I reduce 8 over 12, it reduces by 4, so 2/3. Negative 5/12 does not. 4/12 reduces to 1/3. And negative 1/12 does not reduce. That is your inverse. Again, what are we going to do with that thing? We will talk about that next class. All I care about is, can you find it? So things that this video covered: how to add and subtract matrices, how to multiply matrices, how to find the determinant of a matrix, and how to find the inverse of a matrix. There's a lot more to go with this, but as of right now, that's all you're responsible for. Make sure you make note of questions that you have so that you can ask about them in class.